Okay, so here we have a 12 order PVT invariant voltage control low pass filter. Okay, so first thing that will run you over will be a quick introduction to the different blocks that we use for this circuit. So the first thing, of course, is the voltage control filter pass part. And so that's going to be all implemented using operational transconductance amplifier. This circuit can be found in the literature as GMCs. So this is this section right here. And all of those dual inline package ICs are just operational amplifiers, op-amps, that implement the second order low pass filter blocks that have been cascaded. Okay, now for the PVT invariance, we require the use of a voltage control oscillator. So that's this IC right here. All it is an integrator, a Schmitt trigger, and a switch. The switch has been implemented with a MOSFET, and the output of the integrator is a triangular wave. The output of the Schmitt trigger is a square wave. We use the triangular wave since the higher frequency components are very, very little, so it's the one that is closest to a sine wave. And since the filter we are using has a very, very, very high roll-off, then it's basically a sine wave. The approximation is very, very good. Okay, the other thing that we needed for the PVT invariance was a peak-to-peak detector, which we implemented just with the simplest peak detectors, which are just a capacitor and a diode. And then so we have the positive peak detector right here, and we have the negative peak detector right here, and then we have a difference amplifier that takes the difference of those two and gives us the peak to peak. We also have some digital to analog interfacing, since now we have a negative 12 to positive 12 volt signals, analog signals, that we have to convert into signals that go from 0 to 5 volts. So that has all to be done giving offsets and amplifications and things like that. And so those ones are implemented using these two op-amps. So let's go over to the digital section. So the digital section is right here. This is just an ATmega microcontroller, and all it is doing is that it is basically sending a test signal to using the voltage control oscillator to the low pass filter, and then monitoring the output and then tweaking the control voltage of the low pass filter to get the cutoff frequency to be at the right point. Okay, so let's run over like a quick thought experiment. So the first thing that you will do will be you will change this potentiometer, which is proportional to the cutoff frequency that you desire. The microcontroller reads that analog voltage through its analog to digital converter. Now, what it does to start with is that it sends a control voltage through sorry, this was the analog to digital converter, and this one right here is the digital to analog converter. Sends a control voltage to the digital to analog converter to the voltage control oscillator with the desired frequency that was set by the user. That gets fed to the low pass filter right here. That gets fed to the low pass filter, and then we know what the low frequency gain of the circuit is, so we can calculate 3 dB frequency. That's the negative 3 dB frequency that's calculated in the microcontroller. So now all we need to monitor is the peak to peak amplitude, and then we start modulating the control voltage until we get the peak to peak amplitude to be at the negative 3 dB point. Once we find that, then we say, hey, the circuit has been calibrated, and this is implemented every time the frequency changes, just by the desired frequency changes for any reason. All right. And then finally, we got an analog switch right here. All it does is that every time we want to recalibrate the circuit, we isolate the input signal to be able to send our test signal. right? And then once the circuit has been recalibrated, then we switch back and let the user put his or her input signal. Alright, so that's basically how the circuit works. It's a little more complicated since we had to, the voltage control oscillator, the output was non-linear, so we kind of had to use the same scheme to calibrate it too. But those are just little problems that we run into. Okay, hope you enjoy it. All right.